Here's a nice little question on the topic of power from Edx M2 Jun 2010, question 4. As usual, pause the video and read the question and carry on when you're ready. So here's a diagram that I've already drawn showing the car going up this slope, up the road. Theta, we're given sine theta is a 15th. We're told the resistance to motion is constant. I've shown it here, and they've told us it's got a magnitude of R newtons. I haven't labelled the normal reaction because that's not going to come into this question. We don't need to find it. Okay, and what we know is that P, the power, is 15,000 watts, 15 kilowatts. And the first thing you need to write down in a question on power for a moving vehicle is the relationship P equals FV, where F is the driving force of the vehicle and V is the instantaneous velocity. So at the moment we've got to show that the resistance is 260, and we know, if you read the question carefully, we know it's going at a constant speed of 20. There's no acceleration. So, using P equals FV, we can find the driving force. Let's do that first. So 15,000 equals F times 20, giving us F equals 750 newtons. We're trying to find the resistance. So now we'll resolve down the plane. Remember, this angle is theta. Resolving along the plane. There's no acceleration because it's going at constant speed. So F up the plane must equal R plus 750g sine theta, which is 1/15. Well, we know F, so this is going to give us equation for R. So 750 equals R plus 750g over 15. And that gives us R, the resistance to motion. We've got to show it comes to 260, so hopefully it gives us 260. Use your calculator and check it. R equals 260 as required. 4 marks for that part of the question. Might as well deal with where the marks were allocated there. There was an M1 for using P equals FV, power equals FV, an M1 for resolving down the plane, along the plane, and putting acceleration equals 0, and 2 accuracy marks, one for the answer obviously, and there was an accuracy mark for resolving correctly, and that's 4 marks for the first part. On to the second part. I've copied the second part in on this page as well. The power is increased to 18 kilowatts. Let me just write that down. P equals 18,000 watts. R is still 260. I've shown that on the diagram over here. The car at this instant is moving, we're told, at 20. We've got to find the acceleration. So I'll just put the line there and put theta in the diagram. It looks wrong without it there. Right, well, all we have to do here, pretty much the same as before. First of all, let's find the driving force from P equals FV. So 18,000 equals driving force times 20 in this case. And that gives us a driving force of 900. So in this case, with the driving force now increased to 900, there is an acceleration. So now resolving along the plane and using F equals ma, we get F, instead of F, let's put 900. 900, which is the F, minus 260 minus 750g times a 15th for sine theta equals m, which is 750 times a. So we know everything in there. We've only got to use the calculator now and work out the acceleration, and we'll get our 4 marks. A works out, do check it yourselves, A works out as 0.2. And the allocation of the 4 marks for this part of the question: 2 method, 2 accuracy, a method mark for finding f, and a method mark for resolving, and an accuracy mark for resolving correctly. It's the same as the first part really, and an accuracy mark for the final answer. And that's that question done, number 4.